Hi, and welcome to my video on the index laws. I'm going to go through the basic principles behind index laws from the really basic ones right up until the negative and rational index laws. So bear with me, it will take a little while, but you can skip forward, jump back and find the index laws as you need to. First of all, I'd just like to identify that I'll typically be using A as my base number, and M or N or something else as my index number. And that's also the language I'll be using, as well as possibly power or exponent. Let's start. So first of all, law number 1. It's quite a simple one, and that is that a to the power of 0 equals 1. Easy as, any number to the power of 0 equals 1. Law number 2 is also quite simple. A to the power of 1 equals A. Any number to the power of itself is equal to A. Law number 3 gets a bit more interesting. A to the power of m times A to the power of n is equal to A to the power of m plus n. So I'm going to go through and give you examples to demonstrate why this is the case in each of them. So here's my first example. Note that this only works if the a's are equivalent, so if I had the same base. So let's imagine we had 3 to the power of 4 times 3 squared. According to the law, this would equal 3 to the power of 4 plus 2, which will equal 3 to the power of 6. And according to what we know of index numbers, this will be equal to 3 times 3 times 3 times 3, that's 3 to the power of 4, times 3 times 3, that's 3 squared, and that of course is equal to 3 times 3 times 3 times 3 times 3 times 3, which is 3 to the power of 6. And you can of course build this argument up algebraically as well. Law number 4 is that a to the power of m divided by a to the power of n, also a to the power of n over a to the power of n, is equal to a to the power of m minus n. And by way of example again, let's use 7s this time. 7 to the power of 8 divided by 7 to the power of 3. According to the law, that should equal 7 to the power of 8 minus 3, which is equal to 7 to the power of 5. And in terms of a fractional form, this is equal to 7 times 7 times 7 times 7 times 7 times 7, 7 times 7, divided by 7 times 7 times 7. So there's our 7 to the power of 8, and there's our 7 to the power of 3. Of course, this 7 cancels with that one, this one with that one, this one with that one, leaving us with 7 to the power of 5, which you can see there. So that's law number 4. Law number 5. Law number 5 states that a to the power of m to the power of n is equal to a to the power of m n. And again, by way of examples, let's use 2 this time. 2 to the power of 3 to the power of 4. Well, according to the law, this should be 2 to the power of 3 times 4, which equals 2 to the power of 12. And according to what we know, 2 to the power of 3 is 2 times 2 times 2, and to the power of 4 means that there is 4 groupings of this, times 2 times 2 times 2 times 2 times 2 times 2, and if you have a close look at that, you'll see that there are indeed 12 2's. So that works. Now we're on to our laws to do with negative and rational numbers. So first of all, law number 6, I'm going to break it up into 2 parts. So the first one is a simple version of law number 6, and that is that a to the power of negative 1 is equal to 1 over a. This doesn't give us all the examples of law number 6, but it's a good place to start. A negative number reciprocates the value if the negative number is in a power. So you see here, this is called the reciprocal. In common terms, you might think of it as flipping it upside down. And the second version of this, which is a bit more complex, is a to the power of negative n is equal to 1 over a to the power of n. And really, this is the law that you should be working with and remembering. That's law number 6. Law number 7, again, I'm going to break it into parts. First of all, a to the power of a half, as a specific example, is equal to the square root of a. That's a really basic version of law number 7. The next version of law number 7 is a to the power of 1 over m. Well, that's equal to the mth root of a. So that denominator in the fraction, if there is a fraction contained within your power, well, that represents the root that you need to take. And of course, this root means the mth root of a is the number such that when you multiply it by itself m times, you will get a, what you started with. And the third and complete version of this is that a to the power of n over m is equal to the mth root of a to the power of n. So that numerator is just contained within the power and remains with the a. That's law number 7, and of course, as with law number 6, this is really the one that you should be holding on to. And one additional little sub-law is that law number 6/7 together create this final index law. A to the power of negative n over m is equal to 1 over the mth root of a to the power of n. So those two laws combined create one law. This is very complex, but may arise at times, so you need to be aware of it. In my next video, I'll be taking you through some more specific examples, both algebraic and numerical, for how to apply these laws. Thank you.